Hey everyone, welcome to this tutorial series on how to work with Arduino. Arduino are these boards over here, and you usually get them with a kit with a number of components in them. And in this video series, we're going to be talking about all those components and getting them to do cool stuff. So this is the first video. We're going to be talking about a bunch of the basics, and I'm going to try and kind of simplify it so that it kind of makes sense, or hopefully it makes sense and you're able to put things together. So without further ado, let's go ahead and get started. What I'm going to need you to do is go to this website over here, www.tinkercad.com/circuits, and you're going to need to create an account before you get started. So there should be an option to create an account, and you'll have to go ahead and set one up. If your school has a Gmail account or something, you could probably use that and just set it up. And when it loads for the first time, it's going to take you to the 3D model section of TinkerCAD. So when you finish up registering, it's going to take you to the 3D model part. But then once it does that, I just want you to go back to tinkercad.com/circuits and scroll down until you see this button over here, Launch TinkerCAD Circuits. And then click on that. And it's going to take you straight to the program, so you'll be able to essentially put something together. So we got our workspace in this area over here. If you lose your components, that thing that was down here for a second, you can easily get them back by just clicking on this components button, and then they'll pop up over here. If you want to edit your code, you click on this button, and then if there's any code that you have, it will be over here. And the great thing about this program is it does it in block format, but it also does it in the C-type variation of Arduino. So you're able to copy that code out, go into an Arduino compiler, and then compile it onto your Arduino board. So just some really cool stuff. Let's go ahead and get started. I want you to grab a couple of components to start. And let's go ahead, grab a 9-volt battery, and that was over here, as well as an LED. Okay, so just these two components. If you want to rotate something in this program, we have this option to the side here. I don't know if it's being cut off on my screen, but it looks like two triangles. And if you click on that, you'll actually have the ability to rotate the part. Now, you can also add wires, and adding wires is fairly straightforward. If you just click on the end of a lead, you're able to connect it to another end. So if you're ever not sure what end to click on, let me press escape a few times. You can hover over it, and it will also indicate whether or not it's a positive or a negative. And that is actually kind of important because you need your electricity to flow from positive to negative or negative to positive, depending on how you want to see it. But as long as there's some kind of current or some kind of flow happening in the circuit, you're probably okay. But anyway, we got a negative on this battery, we got a positive on that end, and over here we got a cathode, and we got an anode. And the general rule of thumb is that the positive end is going to go to the anode. If you actually have this LED in real life, or if you're looking at an LED, you're going to notice that one of the ends is longer than the other end. So that's the positive end of the LED. And this is the positive end of the 9 volt. So we're going to run it through there. So I'm going to take that positive end, run it to the anode, and then the cathode is the negative end of the LED, and we're going to connect it to our negative lead on a 9-volt battery. So just going to connect these two together, and then there's a button here that says Start Simulation. If you press that, you're going to notice hopefully that it compiles and that it lights up your light. Now unfortunately it burned out your light bulb at the same time. Why? Because we sent too much current through this LED. Current is the flow of electrons or flow of electrically charged particles through a system or a circuit or a loop, however you want to see it. And when we hook a battery directly to an LED, because there is no resistance, the LED essentially burns out. It's too much flow. I want you to imagine that you're drinking water. You know, if you have a cup of water and you're drinking it, that's okay. You can totally drink the water. But if someone takes that cup of water and tilts it up all the way really quickly into your face, I mean, you're not going to be able to drink all that water. It's going to fall all over your face. So essentially that is what's happening here. We're connecting 9 volts. It's putting way too much current into that LED, way too much voltage, and it just fries that thing. So what we're going to do, that's just an example of electrical flow, is we're going to use the Arduino and some resistors and this LED to kind of regulate this entire system. So I'm going to go ahead and stop the simulation. And it's important that you stop it, otherwise you won't be able to interact with the screen. And then I'm going to click on this battery here and press the delete key on my keyboard to remove it. So all I'm left with is the LED. I'm also going to add in an additional component, the Arduino Uno. And you'll also need a resistor. And if by chance your screen doesn't look like mine, you can always just type in the words over here. So RES for resistor, and then we have a resistor here. Now a resistor is going to resist the flow of electrons. So it's going to reduce the current flow. And there are bands on these. We'll talk about what those bands represent at a later time. For now, most resistors will be sufficient at keeping this LED okay. Okay, and let's also add in, or actually, this, you know what? Let's go with this for now, and we'll add in the third component after. Okay, I want you to take that LED, I want you to take that resistor, and I want you to plug it in the according way. So power is coming from any of these digital ports over here, and we'll explain the significance of digital and analog and these in a future video, but we got power coming from any of these ports over here. So if I took port A, this is positive right now, I'm going to connect it to the resistor, connect it to the LED, and then connect that, which I'm on my negative end now, that's my cathode, I'm going to connect it to the ground. Okay? So what I've done here is I've created a closed loop. And in circuits, it's very important that whatever we do, we always end up with a closed loop. So you'll always notice that I go in a loop, and sometimes there'll be an additional wire that sends out a signal, but it always starts and ends in a loop. So as long as you have this, you're okay. Now, if I started the simulation, you're going to notice that nothing happens. And that's just because there's no code on this Arduino Uno. So we need to go ahead and add some kind of a simple code to make this work. So I'm going to stop simulation. I'm going to go to my code editor, and by default when you drag it on Arduino Uno, it's going to give you this generic 4-piece code over here. Now it just says set built-in LED to high, wait 1 second, set built-in LED to low, wait 1 second. Okay, so I like how that's set up, but it's not going to work for this LED we have here. So I'm going to grab this and throw it in the trash can. Okay, that's been thrown away. Now let's add in the one we want. So in your outputs, go to the one that says set pin blank to high. We're going to grab 2 of those. And then go to your control and grab 2 weights. And I'm going to stack 1 weight there, close that off, and stack 1 weight there. Okay? So that's what my code looks like. I'm going to zoom in also a little bit more so you can see that a little bit better. And if you recall, at the start, I plugged in the LED to port 8. So I need to set pin 8 to high. Now, these are digital ports. So high essentially means that it's on. So it will essentially be saying like, hey, if you send high through here, it's going to power it up. And low means that it's off. So it means there's no power running through there in a sense. So when I say set pin 8 to high, wait 1 second, then set pin 8 to low for 1 second, it's going to go on for a second and then go off for a second. Once it reaches the end of the program, it's going to loop back to the start and it's going to run it again. So essentially we're just going to have a blinking light over and over again that's going to represent that circuit. Okay, so let's go ahead and see what happens. I'm going to hit start simulation, and if you did it correctly, that light should be blinking on and off. Okay, before I end, even though this is working, I want to point out a few other things. One, the code that we wrote here in this block is written over here as well, and we can copy that code and paste it into the Arduino compiler, which I'm going to show you in the next video so you get the general idea of it. And two, this resistor, you might have noticed I plugged it in at the start before the anode, and it made it run perfectly. But in reality, you could take this resistor, and I'm going to delete, whoop, I didn't mean to delete the resistor itself. I just meant to delete the wires. You could take this resistor, connect it to the ground, and I could take this and plug it directly into 8. So there's no resistor here, and I could run this, and it's going to run the exact same. It's not going to burn out the light bulb. And the reason why is that this resistor, if you think about electricity, it acts almost instantaneously. So the second I power this on, it creates a current or a loop immediately throughout those wires. So what that means is, here, let me try to give you a good comparison for it. If you have like a dam how about this? If you're running and there's quicksand along the 200-meter lap you got to run, okay? It doesn't matter if you encounter the quicksand at 50 meters or if you encounter the quicksand at 150 meters in the race. There is still quicksand over there, and if you're running the same pace throughout, that quicksand is still going to slow you down the exact same amount. So it doesn't matter where you put that quicksand, the same reason why it doesn't matter where you put that resistor. As long as it's in the loop, it will act, and it will react and work accordingly. Okay, so if you have any questions, let me know. I'm going to continue this in my next video, so I'll see you then. Peace.